Thank you for coming. Thank you for staying, more importantly. So, it's always very boring to see someone have to set up. You could have just slid out, got a coffee, which would be way better for you. My name's Alan, and I'm going to talk about APIs. This is a high-level overview of the different types of APIs there are in terms of architectural styles. GraphQL, REST, RPC. Practically any API can be realized in any style. It doesn't really matter. So we're going to look at each one in turn and look at the pros and cons of each one and maybe help you pick which one makes some sense for you. Start RPC APIs. RPC stands for Remote Procedural Call. These are the old APIs in the world. They're the original ones. And you can see the clue is in the word procedure, because we no longer use that word functions anymore. So an RPC API is simply calling a function on a different server. That's literally all it is. It does exactly what it says on the tin. Some common implementations: JSON RPC, SOAP, gRPC, tRPC. You may have heard of SOAP if you've done anything vaguely enterprisey. Hopefully the scars are fading a little bit by now. It's an experience using RPC. Sorry? JSON RPC is around, that's a quite nice JSON version. gRPC came from Google, and that's quite binary. tRPC is a brand new one on the block, and that's related to TypeScript. You tend to require a schema, because you're going to need to understand which functions you call and what parameters each function takes. In JSON RPC, there's not one built in, so people tend to use OpenRPC. SOAP has WSDL, I'm sorry for bringing that word up. Protocol buffers for gRPC. tRPC, because it's TypeScript, you can run it on the back end, you can run it on the front end, you share the same file, it just magically happens. It looks something like that if you're going to do a call in JSON RPC. So we'll talk about some HTTP calls over the wire. We post into an endpoint on a particular port, and we send a payload. There's some better data in there, but the important ones are method and params. You're literally calling a function on another server. Dead easy. And you get a response back in a very handy property called result. And you'll get your answer. In this case, we created a user, and we get back their ID 1, 2, 3, 4. That's all there is to RPC APIs. RESTful APIs. I imagine you've all heard RESTful APIs. They've been around a while. You've probably integrated with them. Some of them have been quite so good, some of them have been less good. You've probably dealt with them before. The key thing about them is that they operate on a representation of the state of a resource, which is quite a mouthful, but it gets to the heart about what RESTful APIs are, and they're very much more HTTP based, because it's an HTTP native solution for talking over the internet. We're using HTTP verbs to tell the server the different type of operations we're doing: get, post, delete, etc. We're using status codes to transmit information back to the client, 200 series for successful ones, 400 for errors, etc. We're using headers for content control, for content type control. We can do things like that because it's all HTTP native. We use hypermedia controls, and because this is software engineering, we like to use really long, complicated words for things that are quite simple. So hypermedia controls simply means links. That's all it means. We're used to links on our web pages. Hypermedia controls are links in our APIs. The idea behind them is that we need to do state transitions. We need to know where to go next after performing an operation. The links tell you where to go. So for instance, you raise a new order. The response back from creating the order might have a link to the invoice, might have a link to the shipping status. Things like that would be in your API payload. We call them hypermedia controls. Makes discovery and the ability to manipulate where these things are really, really simple. But most RESTful APIs can't be bothered to implement them. They're relatively rare. As a result of that, we can use OpenAPI specs instead, which is a bit of a shame because hypermedia is awesome. This is what one looks like. So again, we go create user, so we post to a particular collection this time, /users. So we're going to create a user on the users collection. We have to pass content type in. What's the content of this actual payload? And we state what type of content we set back. So this makes forward compatibility that much easier. We can change from, don't get too scared, XML to JSON relatively easily because we control it via the headers. HTTP has all this built in for us. And our payload is quite simple, so we get back some sort of response. There's that status code to a one created. So the client knows that this was a successful call. Content type is HAL plus JSON this time. So we're providing additional hints to the client on how to decode the body. In this case, HAL format means there will be an underscore links object within the payload, and that's where our hypermedia is. In this case, you can see it's the link to the user that has been created. E-tags, yet another header that we can use in RESTful APIs. E-tags are wonderful. If you've not done much with them, they're worth reading up on. Obvious thing you can do with them is you can detect an edit clash. So you've got two clients trying to change the same record at the same time. It's detectable using the e-tag system. It's a built-in standard of HTTP. It's also really good for content caching. So you can send the e-tag on your next request for a GET request, and with the if match header, and the server doesn't have to do any work if you've got the latest version of that particular resource. So we can save server resources because we can send, oh, this is my cache version, does it match the latest version? That sort of stuff built into REST. GraphQL APIs. I used to say this is the new kid on the block, but more accurately it's the newer kid on the block, because 2015 is actually not so recent nowadays. Facebook invented this for the problems they had. So specifically, they had a set of problems with their particular application. They call it the Blue application, and it's fairly popular in the world. It has quite a number of daily visitors, and they found that they needed a better way to handle data, and more importantly, they wanted to put more business logic into the client. And GraphQL is a really good solution for that problem. If you don't have that solution, maybe GraphQL is not the right one. Key things you can do with GraphQL APIs. You retrieve only the data you need on the consumer side. Client picks which fields they want from each object. You can reduce the number of round trips, the number of calls that you make to the server, because you can nest data. You can get sub-resources out within the same request. It has a self-describing typed schema. This is cool. This is clearly one of those learnings that came from the past. It turns out it's really helpful to find out what the API can do. And I don't know if you know this, but nobody reads documentation. Absolutely no one reads the documentation. So if you put the documentation into the thing itself, people can find it. And in terms of the ecosystem, it means that something like Postman with a GraphQL API can do autocomplete on all the properties, because it's a self-described API. It's really, really cool. It's a really nice feature. And you build up queries that look something like this. So to do reading and writing with GraphQL, there are two types. There's reading, which is a query, and there's writing, which is called a mutation. Let's quickly look through how a query works. So we have that query tag at the top. It looks vaguely JSON, but it isn't. Don't get fooled. We're going to look for an author. So we use the author tag there, and then the bit in brackets is a kind of filter or a limiter on the collection or the item. So here I'm saying I want the author whose name is Anna Caffrey, and then we get to ID name, which is a specification from the client side of which particular fields I need to come back to me for display on my application. And there's my embedded resource. I would like a list of Anna Caffrey's books. Again, I put a filter on there. The first 5 is enough. A total count will tell me how many books in total are in the entirety of the record set. And then we have the edges node where you can see the GraphQL bit kicking in slightly. And ID and title is for each book. So the node label there represents each book in my collection. You can result back. Handily, it's keyed by the word data. Now this genuinely is JSON, which makes it easy to pass. There's our author object, and there's our ID and name. You note we don't get anything else because we didn't ask for it. There's our books embedded collection. You can see the total count is 6. So there are 6 books from Anne McCaffrey in the database. And I have done Anne McCaffrey a disservice because she has written way more books than that. I was getting bored typing them into the example. And then how our edges and our node, and you can see Dragonflight was the first book. Mutations work basically the same. So which do you pick? I don't have a particularly strong view on this. I'm an independent API consultant, which means that I do what my clients tell me. Sometimes they ask my opinion, and sometimes they even listen to it. Rarely, because clients are very opinionated at times. Having said that, you do need to make a decision. And how do you make that decision? What are the pros and cons that make the most sense to think about for any given particular application? Let's start by thinking about Lamborghinis and Ferraris. My eldest son is a Lamborghini fanatic. He absolutely loves them, has done since he was yay-high. He collects die-cast models of them at 1:24 scale. He absolutely loves Lamborghinis. My wife is more of a Ferrari person. She likes Ferraris, always has done. She started with Testarossas. There's a big poster on the wall, and that dates us quite a lot as a result. Which one do you pick? Doesn't really matter. They do basically the same thing. They go very fast. They go round and round very, very quickly and use lots and lots of petrol. It's a preference. Take your pick. At a certain level, the one that you prefer writing is the one you're going to do a better job at. So if you would prefer to write a GraphQL API over a RESTful API, and everything else being equal, then you're probably going to do a better job with GraphQL API, because you prefer it. And let's face it, nobody ever wants to write another SOAP API in their lives. Now this choice, Lamborghini or a truck. My youngest is at university, and in a few weeks' time I'm going to have to collect him and bring all his stuff back. All his stuff back. It's been 3 years. We took a little bit and it seems to have grown. Now, there's now a distinct difference between which vehicle makes most sense for collecting all his stuff. I could take the Lamborghini if I happen to own one, but I doubt I would get his collection of cars in it. The truck, I could fit all his stuff in. Definitely right vehicle for the right choice. And there are some important differences between the API architectures that might make a difference for building your actual application. So let's look at those. Considerations. What's it to be used for? Do we need any response customization? Do we care about HTTP and interoperability? What's it used for? Do you control both the server and the client? So do you make the app as well as you make the server, and there are no third parties involved? If you're in that situation, something like gRPC or tRPC becomes viable, much more viable than if you don't. It's much harder to use gRPC with lots of third-party clients, for various reasons, mostly around complexity. And that comes down to the skill sets of your expected user base and how many you expect of them. And what is their expected ecosystem. If you are working in an enterprise environment where there's an awful lot of built-in knowledge within that particular industry, and they're all used to using, I don't know, SOAP APIs, then maybe writing a SOAP API makes more sense. Unlikely, fortunately, nowadays. More likely they're going to know REST, but we'll see. If you've got a huge amount of users, you need a lot of scale, then you're going to start thinking about how much data you're transferring over the web versus how much control you want. And response customization comes to that. For GraphQL, it's a query-first language. You choose your fields, you choose your nested resources. So you're giving up that to the client. RESTful APIs are a lot less customizable. You can see some customization in RESTful APIs. So if you've got a resource that's got an awful lot of properties, sometimes you'll see the API provides a filter for simple or advanced or simple or full or something like that. It's relatively rare. RPC, you don't get a choice. As a general rule, RPC API, it's like calling a function, you get back whatever the function gives you. That's all they do. So if you need to control the data that's coming back, you'll consider GraphQL. None of this actually affects the performance of your application as much as your data layer does. So just because you're saved a few bytes over the wire, if you're really slow at your data level, it doesn't really matter in the grand scheme of things for time to first byte, because that is, you're looking at the wrong point. If you're only worried about bandwidth considerations, however, then response customization is really, really important. Performance. REST and RPC are server performance first. The server is the most important thing. It is the primary in our relationship here. And for RESTful, because of HTTP, we are talking client-server type relationship, then the client should not know your business logic. That is the province of the server. GraphQL is the other way around. The client is in control. The server isn't. The business logic is now moved to the client, not to the server. That's one of the fundamental differences between them. You're giving far more control to your clients with GraphQL. You can cache all of them. You can cache RESTful API better. Essentially, most of your caching is in your application layer, so they all work perfectly acceptably at that. But then when it comes to trying to cache data resources, with RESTful APIs we're using GET, so we can use proper HTTP caching, what you can't do with the other API architectural styles. Errors. RPC, you'll probably get some sort of result equals false. It's a bit like calling a function, it just fails. It's not very interesting, it's quite difficult to handle. REST will use HTTP semantics. So we've got status codes, we've got standard error codes. And GraphQL is going to use a top level error object. So REST errors look something like this. In this case we have a 503, which means that there's nothing the client can do. If it was a 4xx, then the client could do something to try to resolve it. And then you're going to have some sort of payload that tells the client what the problem is. This is RFC 9457 format. I highly recommend you use a standardized error format. It makes life so much easier for every client. And if you don't have one, RFC 9457 is the one to follow, because brighter people than me, at least, invent it. GraphQL looks like this. You get an error section. We still get the data. So if some of the data can't be collected, you're still going to get the data it can be found. And this is all part of the fact the client is in control. The client is the primary in the relationship. So the server has done its best. And then you read the error section. So we've got a message, our name for character with ID 7 cannot be fetched. And it'll tell you where it is in the path. So it will be in the front section, it will be the second element because it's zero-based counting, and it's the name element within that, and you see there's a null there. But maybe the rest of the data is enough for continuing your operation. Obviously, if your GraphQL server is completely down, you're going to get a 500 error anyway, because that's the way HTTP works. Versioning, no matter what anyone tells you, they can all do versioning equally well. Versioning is hard, But evolution works all the time. Try not to create a backwards incompatible change if you can possibly help it, no matter what your architectural style. You're in for a world of hurt, let alone your users. One thing GraphQL is really good at, though, is deprecation of properties. So if you've got a payload of, say, your user object, and it's got 15 properties in it, and you've deprecated 3 of them, because in GraphQL you know which fields are being used, you can determine when your deprecated fields have stopped being used, or who is still using them. And then you can contact that really important customer that represents 80% of your business and ask them very nicely to move on. This stuff is hard. It's always hard to do good design. And that's no different for APIs than it is for websites. Basically, we need to balance developer experience against the internal app's capabilities. GraphQL, big issues are normally around naming and choosing what can be nested and organizing the structure of the nested resources. As a personal top tip, don't replicate your database architecture into your GraphQL API. I don't need to see your database schema. It's normally not what I'm looking for. Main problem with GraphQL is it's really easy to create a denial of service attack on yourself. Because the client is in control and can ask for the world. And if they ask for the world and all of them do it, suddenly you don't have enough server resources. So there's a concept of complexity that's added into GraphQL to determine, can we actually fulfill this request in a sensible length of time, or should the client simplify it? So design considerations there to think about. For RESTful APIs, you need to balance the amount of data being sent versus the number of requests that need to be made. That's your primary consideration. It's easy to end up with clients making too many calls, for instance, for the actual data they need to do. And that's where you start seeing the back-end and front-end type APIs coming into play. On the plus side, uniform interface, the HTTP nativeness of RESTful APIs, and their ubiquity makes them very easy to understand and work with, and quite easy for adoption. It's your choice. Fundamentally, it's all about control. Where do you want the control to be? Do you want to be at the server, or do you want to be at the client? Going back to Facebook, Facebook would be controlling the client because they got free processing power from all their users who have phones, and they're not paying for that processing power. And they've got 2 billion daily active users, so that's a lot of processing power. And the more processing power they can offload to the client, the better. The average bank is a little bit more concerned with keeping the control tight. They have a different set of priorities. That affects your choice in a lot of ways. So the big part of GraphQL is that control, limiting the multiple round trips, choosing the amount of properties that go down to the client over the wire on the bandwidth. If that doesn't matter to you, then don't necessarily use it. RESTful APIs, as I say, the ubiquity is a huge benefit. I'll leave you with this. This was said by Arnold Laurent, API handyman on the interwebs. He wrote a really good book, I recommend it. If you suck at providing a RESTful API, you will suck at providing a GraphQL API. The actual API architecture does not affect the quality of the actual product. That's down to your ability to do a good design. As it's newer, GraphQL APIs tend to have learnt from people who wrote really bad RESTful APIs, so they tend to be better because they're their second or third attempt at writing an API. Similarly, however, good RESTful APIs have been built on the foundations of other RESTful APIs. It's all about your experience and how much design work you put in. I like them both. I'm happy to use either. I would far rather use a SOAP API that's been well designed than a badly designed RESTful API. Thank you. I appreciate it's break now, but feel free to ask questions if you'd like.
Where does the JSON API fall into? It's a REST API, right?
JSON API is a RESTful API. It's very common. One of the most famous ones at the moment is Ethereum. the Ethereum current blockchain thing. It's a JSON API. It fitted their ecosystem. It's quite nice, but it's very much request response. Call the function, get the answer.
What's your favorite in Drupal?
I don't use Drupal very much. From my point of view, I'm at the other end of the API chain, so I tend to be working with the legacy side, and we're trying to get data out that then the Drupal people are actually pulling in. Drupal have got a plugin for GraphQL now, and they've got a RESTful API as well. The GraphQL API is quite interesting because they have improved it over time. The new one is version 4, and they've vastly improved the default data sets in it, which make it better in a lot of ways. So I think going back to it doesn't really matter, but a well-designed one makes a lot of difference. The evolution of the Drupal's GraphQL module, or I think they're called modules or plugins, where it is, it's definitely going the right way to make it a very nice way to get at the Drupal data. And I imagine it's used quite a lot on headless apps.
Thanks a lot, I'm the GraphQL maintainer.
Okay.
Nice to hear those words. Yeah, we have this interesting effect that now there's the GraphQL core module where you design the schema yourself.
Yep.
Like you said, you don't expose your whole database structure. Now it has popped up 2 additional modules on top. I think it's GraphQL Compose and GraphQL Core Fields or something like that. And what they do is they just dump the field structure as it is in Drupal as a schema out. I think it's helpful for people because they don't need to design a schema. But from your perspective, it's not good.
Drupal's got a slightly different scenario to most of the ones I see, but my point about you don't expose your database schema to the web is really, really valid for a number of reasons. And the number one reason is coupling. You basically coupled what's happening in your database to the view layer. And software development, coupling is normally a brittle point of problems later in the future. You don't realize it until you get there, and you bitterly regret you did that coupling. But it does make things easier at the beginning. So yeah, you give everything to the client, and the client goes, "Oh, I have that. Oh, awesome!" And because this is a Drupal specific bit, the people writing the front end are probably well aware of how Drupal works internally. So it's quite helpful for them just to pull the data they know because they understand the internals of Drupal. Elsewhere, you don't really want your front-end people having to understand the internals of the back-end system just to get the right bit of data out. It feels quite lazy to me. You're abdicating your responsibility as an API developer and API designer just to do that. I think you can do better, basically. It would not be my choice, even for a headless CMS. Does it help? I'm aware I'm starting to rant now.
Perfect. Thank you.
Let's stop there, because...
We're going to have the break, and I think in 3 minutes the next session is coming.
So thank you very much.